Welcome to my YouTube channel, and this will be another video presentation on testing another AC based appliance. In this case, again, another motor, AC motor type, and the motor that you see in front of you, this thing right here with its allotted, you could say, windmill. This device came from a broken enclosure wise room air ionizer or air freshener, also called air purifier, which had its enclosure destroyed in the process, and I was able to salvage this motor along with the windmill that you see in front of you. So this video presentation again will be centered on as such using the services of my homemade Variac device. And for voltage references, I'll be using my digital multimeter, VoltCraft VC404, and perhaps I'll be needing again the services of my massive Vise in order to put the motor in and make everything safe for testing. But I don't know whether I'll really need it, but it's better to have it handy than need it but don't have it around. So I'll be again using my screwdriver to secure every connection in this coupling over here, and I have an additional green Alligator clip ready wire in order to establish the connection from this end of this green wire, which is mounted on the motor, into that black wire here in order to ground everything and make it safe. That will be guiding you through this entire presentation will be again my humble self, David or Dave. So now, as usual, I'm going to show you this motor and give you a brief rundown or description of thereof. So firstly, this motor comes with this windmill, which is detachable. It can be removed, so this can be, discarded, and you can just use the motor. So this is how it looks like, everything detached. The actual windmill has about 22 blades all around. It has been cleaned naturally. So the overall length as such is stated or measured at around 26 centimeters, and the diameter being also at around 6 centimeters. So this is again how it looks like. Here the axis on the motor would go in. It's a sort of a rubbery thing in order to secure it nice into place. And then on this side, that part comes in. It's a bit oily as well to give it sort of a nice free flow when it rotates. Yeah, so this is it. So this part isn't really worth mentioning. Just some sort of a, plastic with a brass fitting inside. So that's it. Now, in regards to the actual motor itself, let's start first with the axis. The axis sticks out about almost a little less than 3 centimeters, 2.6 to be precise, and the diameter of thereof is a little over than 6 millimeters, 6.3. The motor itself naturally runs on 220 volts AC. It uses up about 300 milliamps, so total power consumption is around 66 watts. But you can see that also on the label right here, a little goldish color. I don't know, you probably won't be able to make up the model, but the manufacturer is Cam1. well, here you can see it a little bit, just that here it's a bit blurred out or scratched out. So this is of course the grounding wire, the green one, and here you have all of these wires coming out of it. So again, let's look at it from this angle. So it's nicely preserved. It has also been cleaned. Practically no rust or corrosion. Let me get this wire away. So, very nice AC motor. The axis spins very freely, so even the ball bearings are still in good condition. So the motor comes with, of course, with this ground wire, which is mounted on the metallic stator. But interestingly enough, it comes with 4 wires, because usually in order to power this type of motor in design you only need 2 wires, for AC, but and 1 for grounding. But here you have actually 4 wires. So what's this about? I decided to do a little experiment in terms of wiring this motor. So I used my digital multimeter to do some resistance checking, because initially I thought that, let's say, the black and the white wire, they were connected together, and that they were isolated from the red and the black wire. But actually all wires they are connected. So let's say if you were to measure the resistance or check for continuity, let's say between the white wire and the red wire, they would be connected, and also between the black wires. Initially I thought that when you would plug in to that coupling over there, the white and the black wire, the motor or the rotor would spin in one direction, let's say clockwise, and when you would connect the other 2 wires, it would spin in the other direction. But this is not the case. But I have, because I have tested this motor prior to this, I have come to interesting conclusions in regards to when you test different combinations of wires on the variac, and I will show you this in the testings. Enough rambling on, I'm just going to power on the variac, I'll make all the necessary connections on the coupling, and we'll start playing. Probably going to divide this entire video presentation into 2 parts. So in the first part I'll be testing only the motor as such, without the windmill connected onto the shaft, but I will probably attach some sort of a sticky paper on the axis so that you'll have sort of a visual presentation or indication at which voltage the motor starts to spin. The variac is powered on, plugged in through that black input power cable, which is then attached to my AC power cord, and that through this white cable behind it and goes into my AC wall socket. As I mentioned in the introductional video for this device, the variac doesn't have an on-off switch, so as soon as you plug it in, it is working and giving away or generating the output variable AC voltage on this white cable. So I have to make sure that the knob, or in this case this gear, is turned completely counterclockwise as such to the lowest possible voltage, so I don't shock myself when I do the connections or securing everything in this coupling. The digital multimeter is also plugged in through its test probe leads into this coupling, and of course the first combination of wires have also been attached into this coupling, I mean the connectors in thereof. And also the grounding wire has also been established, and I have added this white sticky paper onto the shaft or the axis of the motor, which will give you a nice visual indication at which voltage the motor starts to spin. So now, as usual, I'm going to zoom in on the wiring so we can have a closer look, and then on the multimeter where I have set it in the which measuring range, and then we'll start turning that improvised gear or knob clockwise and increase the voltage. So this is the wiring up close. Here you can see the white cable is skewing the overview a little bit, but nevertheless, this is where I have made the connection with one end of the green alligator clip, and the other side has been clipped onto this wire which goes in here, and this side, of course, you have this standardized yellow greenish wire for grounding, and then into these two holes or openings I have inserted one pair of the wires from the motor, the red and the black wire, and also into these two slots I have inserted my test probe leads. Of course, you know, this is AC, so polarity doesn't really matter. I could also put the black probe lead into this slot and vice versa. Again, also here for these two wires I could also switch them, so this doesn't really matter. So we'll probably start with this combination, then I'll probably, I don't know, use this black wire in this position, and then we'll do all the combinations. So this is how it looks like. Now I'm just going to zoom in on the multimeter. So the multimeter has been set in the 750 volts AC measuring range. This is the AC voltage, so variable, because this motor is rated to work at around 220 volts AC, so we'll be going beyond the 200 volt mark, so you have to set it in this position. So this is okay. The wires also connected as they should be. My black test probe lead to the connector, it's kind of failing, so I'll have to get new wires, but it'll just last for the purpose of this video presentation. So now we'll just start turning that gear clockwise and we'll start playing. I have positioned the camera so that you have a much better overview on the entire experiment. I have also physically moved myself to the right side of the screen, so this will be much easier for me to also have a good visual indication on the entire test. Now, according to my notes, which I have made prior to this video, in terms of this red-black wire combination, the motor should start to spin freely at around 32 or 33 volts AC. So let's see if I was right. So nothing at 32. So it actually starts to spin at around 34 or 35 volts AC. Now let's try if we apply some help to the axis, so rotational kinetic energy. So let's see at which voltage does the axis or the rotor start to spin. I think it's around 30 volts. So it's going to stop. Yeah, so it's not slowing down. So at 30 volts AC, if you apply some help to the axis, this is also the lowest speed at which the motor starts to spin. Now in this combination I have detached the previous black wire that was in this slot, and I have moved the adjacent black wire into this part of the coupling. So this one was before in here, while this one was freely sticking out. So we still have the black or the red-black combination, but this is the other black wire. So we'll see how it is in this configuration. Now, according to my notes, the motor or the axis of it should start to spin when applied some assistance. The motor should start to spin at around 55 volts AC. So this is correct. The motor starts to spin at around 55-56 volts AC when we give it a gentle push on the axis. So let's slow it down and let's see at which voltage does it actually begin to spin freely. Probably at around 60. Yeah, 60 volts AC. So this is the lowest non-assisted voltage at which the motor starts to operate. So again, we'll change the wires, different combinations, and then we'll repeat the procedure. Now in this position we only have the black wires of the motor connected into the slots for the AC voltage generation. So the red and the white are freely disconnected. So we'll see what are the results for this combination. According to my prior tests, the motor, while it is connected in this manner, it should start to spin at around 40 volts. Let's see. So this is meant for if I apply some help to the axis. Yeah, so this is definitely the aid-assisted push to the axis and the voltage at which the motor should start to spin. Now let's put it into a standstill, into a full stop. And let's see at which voltage does it really start to spin freely. Probably around 45. So the motor actually started to spin freely at around 43-44 volts. So again, now I'll change the wires again, zoom in on the wiring, and we'll do the rest of the combinations that are still left. Now only the red and the white wires are in the coupling area for the AC generation voltage. So both of the black wires are free. They're not inserted into this into these two slots. And of course, I have to mention, because I mentioned this when I was describing the motor, because everything is connected, it's not separated. I have to make sure that these two wires don't touch and cause a short and probably blow out a fuse on my Variac. So we'll try this method now to see how the motor reacts. So in this connection, the motor, with the help of some assistance, is supposed to start to spin at around 119 or 121 volts AC. All right, let's see. So it's not really slowing down, so I was right. So it starts to spin at this voltage. So I'm going to stop the axis, and then I'll see when it actually freely starts to spin. probably at around 5 volts higher than that, 125 volts probably. No, so even not anything with 130. So I see some movement. You can see it, it's slowly moving. Maybe at 140, no. So it starts to spin on its own at around 135 or 36 volts. Yeah, so this is it. So again, I'll change the wires and we'll repeat the process from the beginning. Now we have one of the black wires used in the last slot. I have also moved the white wire in this slot where the brown wire is on the other side, because this one was previously here. So we have this combination, and then we'll use the last black wire in this slot. So that will be then the end for this part of the experiment. Then we'll just crank up the motor. While connecting this way, the motor is supposed to spin at around 76 or 77 volts AC with some assistance. Let's see if this is true. Yeah, so this is correct. So this is the lowest voltage when this motor begins to spin when connected in this manner. So we'll stop the motor and we'll see at which voltage does it begin to spin freely. Probably at around 80. No. Let's go up. So at around 86, 87 volts, that is when it really starts to spin on its own. And of course, pretty much in this condition under no load. That should also be taken into consideration. Even though I have this piece of paper on the axis, but this is practically no mass at all. So now we only have to do the final combination. When we swap this black wire with the other one, and then we'll crank up the motor to its nominal voltage. So this is the final combination that there is left. I have removed this black wire which was before here, and I have reinserted the other one. Everything remains the same, so let's go through this last part. Now for this connection, the motor is supposedly start to spin with the help of some assistance around 104 or 05 volts AC. All right, let's see. So it's not slowing down, so this is correct. 105 or 04 volts. So I'm going to stop the motor or on the axis, and then we'll see at which voltage does it start to spin freehand. So 110 or 109 volts. So this is it. So now I'm going to probably use the red and white wires in order to crank up the motor to its nominal voltage. Now this is type of the connection that I'll be using. So when I'll be going to the maximum nominal rated voltage for this motor. So the black leads of the motor have been disconnected, both of them, and only the red and the white wires will be used for this part of the experiment. Again, we'll start slowly with the usual 50 volt increment, and then we'll move up. So 50 volts, now let's go up. $100, now 150. So the motor starts to spin around 130 volts, AC freely. Now let's go to 200. So the noise is starting to pick up. So we're at 200 volts AC. Let's see that the motor is heating up. So this is nice because it's cool. Alright, let's go to the nominal voltage, 220. So this is it. Working fine, cool. Maybe we can even try to go a little higher. Let's go to 230. So the motor is still nicely cool, no overheating. So this is it. So now I'm probably going to do just one experiment with the windmill attached onto the axis. I'm not going to go through all of the color combinations of the wires, because that would really make this video an hour long. I'm already probably past the 40-minute mark. I don't know. I'll see when I'll compile all of the smaller clips into one big video. So we'll stop here. We're at the last minutes of this video presentation. So in this part I'll be using both of my hands because, well, I have attached the detachable windmill onto the axis or the shaft of the motor. On the other side I have this other piece which sort of acts as a frictionless bearing as much as possible. So I'll be using both my hands because in one hand I'll have to hold this and try to keep it steady as possible and also not sort of twisted. So the shaft also on this side of the windmill will be free as possible, so the actual windmill will be able to turn. So this will be very challenging. So I don't have anything to put underneath here or secure it, so even my Vise won't be able to help me in this task, so I'll have to improvise. So now I'll just quickly turn the knob all over the 100 volts to get this windmill moving. Come on. Alright, so this is the sweet spot. Now we'll just go quickly to the nominal voltage to get this moving. So this is it. So this is how it behaves. We have a nice airflow going. also on this side. So of course naturally I won't go through the other color-coded combinations in terms of wiring while using this windmill, because that would really take up a lot of time. I'm already probably beyond the 40-minute mark for this video presentation and such. So I'll just simply wrap up this video presentation on this motor and with the allotted windmill that came from a broken home air ionizer or air purifier. So in conclusion, if you have this video interesting, if you found it enlightening, leave a comment in the comment section below, or just simply like, share and subscribe. This is David, having a nice chilled day.